We'll get started in about 1 minute. Good afternoon, and welcome to this NTMA Tech Team webinar on digital boring tool technology, where it's at and what's up next. My name is Nick Ju, and I'm a research and development engineer here at BIG KAISER. I'll be talking about the fine boring process, where boring tool technology is at right now, and what's coming up in the near future. If you have any questions or comments during the webinar, feel free to message them via the chat system in GoToWebinar, and I'll try to respond to them at the end of this presentation. With that, let's get started. The topics of this discussion are all about fine boring, from the current and older analog technology, the emergence of digital tooling technology integrated into the boring heads, the introduction of wireless communication capabilities, and what we at BIG KAISER believe to be the future of the fine boring process. But first, a brief discussion on fine boring process in general. As you may already know, the fine boring process is the process of finish machining an existing ID bore, or OD boss, to a target precise diameter. Boring a hole with a single point cutting tool, like this one, can achieve tight tolerance diameters, which give better roundness than circular interpolation methods with end mills and likewise. These heads are operator adjustable to move the cutting edge in and out in order to reach this target diameter. The fine boring process usually requires tedious manual intervention to measure the bore and make adjustments to the tool in order to achieve these tight tolerance holes. Because of this manual step, the process remains to be an open loop and sometimes time-consuming process. So first, we'll touch upon the current and most straightforward technology for adjusting boring heads, analog adjustment dials. These boring tools have an analog adjustment dial with hash markings or vernier scale markings that show the movement of the cutting edge. Adjustments are made by rotating this dial with a hex wrench and reading these markings. There's also a clamping screw on the side to lock the tool carrier, which holds the cutting edge, to prevent the unwanted movement during machining. This is a very simple, fully mechanical structure with a fine-pitched threaded rod attached to the dial that moves the tool carrier and cutting edge in and out. Although a quite simple and basic design, these analog-style adjustment tools have some drawbacks and difficulties of use, one of which is the vernier scale markings. These markings can be very hard to see on many tools, especially the smaller ones. The vernier markings can also be very difficult to understand, especially for some unexperienced operators who really don't know how the verniers work or how to read them properly. These markings can also be hard to read properly when covered in coolant and chips and other debris, making it really difficult to look at without cleaning it first, which can be more time consuming. The analog nature also makes it difficult to track previous adjustment values without having to note the new dial positions every time an adjustment is made. This also makes it tricky to track cutting insert wear, as every adjustment would need to be logged or remembered beforehand. The dial cannot show any potential backlash as well, or play in the adjustment dial, since the markings are only related to the dial themselves and not the tool carrier directly. So if the threaded rod, for example, had a backlash internally, that the tool carrier and therefore cutting edge may not be moving by the exact amount shown by the dial, leading to potential errors in sizing or incorrectly machined bore holes. There is also the possibility for clamping error when the side clamping screw is tightened, since pressure is being applied to the side of the tool carrier and could cause some unexpected movement. This error, just like backlash, cannot be determined by the dial alone, and other measurement methods, like using an external presetter or in-machine gauging systems, would need to be used in order to see the actual movement and position of this cutting edge. To help overcome some of these drawbacks in analog-style boring tools, digital tooling technologies emerged and were implemented into these fine boring heads. Similar to how analog dial calipers started getting replaced with digital calipers, BIG KAISER's fine boring tools became digital by getting an electronic display embedded into the tool. These digital displays replaced the vernier scale markings on the dial. Adjustments are still made by rotating the dial with a hex wrench, but instead of reading the markings on the dial, the operator just reads the values on the integrated display. How did we do this? Well, here's a look at the internal scale system inside of a BIG KAISER 310 series EWD boring head. It starts with embedding a magnetic scale into the tool carrier so that the scale moves with the cutting edge and cartridge and not the adjustment dial. A stationary sensor is then mounted to the tool body that detects movement of the scale. This sensor connects to the electronics unit that houses a microcontroller and other circuitry, which calculates and shows the movement values on the integrated screen. Let's take a closer look at the display screen. This screen can show ultra-precise values down to 50 millionths in diameter or 1 micron in metric mode. The digital screen also allows for simple conversion between inch and metric with a push of a button. The display can be reset to 0 for easy incremental adjustments as well. This allows for cutting insert wear to be tracked as well by setting it to 0 at some nominal diameter and then keeping it there and tracking the incremental values as the operator adjusts the tool over time due to wear. So how does all of this help with improving usability of these fine boring tools? First off, the operator no longer needs to rely on the dial markings, of course. They can just read the screen values, making it much simpler and easier, faster to make accurate adjustments. There's also less chance for the operator to make mistakes in adjusting, like forgetting which hash mark they started at, or miscounting the number of rotations on the dial, or even misreading how much one division moves the cutting edge. Another key benefit is that any backlash or clamping error can be seen by the change of values on screen, since that scale is reading the direct movement of the tool carrier and cutting edge directly, not the adjustment dial. So any movement inflicted on the tool carrier will be visible by the value change on the display. These are all great benefits, but there's still some shortcomings to these digital tools. The operator still needs to look at a small screen on the tool body, which can be difficult, especially if the tool is in a hard to reach spot, their spindle is in a harder place to reach, or the view of the screen is difficult, especially to read really closely. Any adjustment calculations between the actual measured bore diameter and the target diameter need to be done separately as well, adding to the chance of human error or typos, stuff like that. Imagine trying to do mental math down to a tenth of a thou. It can get pretty tricky or error prone. And tracking the history of adjustments still needs to be done manually. There's no automatic saving of every adjustment value made, so an operator would need to note all this on a piece of paper or on a computer separately. So to tackle with these problems or issues, this is where more technology advancements come into play. Enter wireless technology. By using Bluetooth Low Energy, sometimes abbreviated as BLE, functionality has been integrated into the fine boring heads that help overcome these issues. Bluetooth is a common communication protocol built into many common devices like smartphones and wireless headphones, for example. We at Big Kaiser chose to use BLE because it allows for much longer battery life and power efficiency for our boring tools. This new style of tool, which we call EWE, gives all the same benefits as the previous digital boring heads, plus some new added wireless capabilities, which allow for scale position data to be broadcasted wirelessly and read by external devices like smartphones and tablets. With external devices being able to connect to these boring heads, special software applications can be developed, like our Big Kaiser app. The wireless communications also opens up the ability to store and retrieve historical adjustment data from the boring tool. Let's take a quick look at what the Big Kaiser app can do to help supplement the Fine Boring tool. Our free app, which is available on the Apple App Store and the Google Play Store, allow an operator to connect with our Big Kaiser EWE boring tools via the smartphone's built-in Bluetooth capabilities. With it, you can access the boring tool information, like tool operation and maintenance manuals. You can also calculate recommended feeds and speeds for a specific tool assembly based on the workpiece material, spindle taper, cutting diameter, and tool projection lengths. All adjustment calculations are done inside the app as well, eliminating the need to pull out pencil and paper or calculator. The operator also easily can view the tool carrier position values on the device on their smartphone while making adjustments to the tool. As you can see here, these three bubbles show all the necessary values to make these adjustments simple and easy. The bubble on the top displays the current diameter of the tool. The bubble on the left shows a relative delta movement of the tool, and the bubble to the right displays the target diameter. So as the operator makes an adjustment on the head, the left and top bubbles change value based on the adjustment movement. There's also a gauge at the bottom of the screen that helps visualize how close to the target you are at. The needle will move to the green middle section when the adjustment is at the center of the tolerance band. Finally, the history of adjustments on the boring head can also be viewed and even exported to spreadsheet files. This is useful for operators who need to track their adjustments, or even shop managers who want to keep track on what their operators are doing with their tools, or to diagnose any issues that may have occurred. These are all great benefits over digital technologies and definitely an improvement over analog technologies. But there's still one issue that really hasn't been improved upon yet, and that is the operator intervention. There's still manual operator intervention required in fine boring. This manual adjustment step in the process, no matter if it's analog, digital, or wireless, is always required. This means that the machining cycle has to have a pause point for the operator to make this adjustment. They can't just let it keep running. The machine door also needs to be open for the operator to conduct an inspection measurement and adjust the boring head as needed, which exposes the operator to potentially hazardous conditions like from chips and or coolant. This also means that the operator needs to be at the machine, ready to make the adjustments, which prevent from unmanned operations or lights out machining from being possible. And how can this be solved? Obviously, we need a tool that can automatically adjust itself, right? And this is where it goes right into this. So we at Big Kaiser believe this to be the future of fine boring. Automatically adjustable fine boring tools, a product line that Big Kaiser is calling EWA. With motors and other electronics integrated into the tool to move and clamp the tool carrier, manual operator intervention is no longer needed to make these adjustments. Everything can be done automatically through the tool's internal components. Let's take a close look at the internal structure of an automatically adjustable boring head. This simplified animation shows the internal functionality of the tool. The tool carrier, shown in blue, has the carbide insert or cutting edge attached. So as it moves, the cutting edge moves. There's the integrated motor in the back that moves the tool carrier in and out, replacing this manual adjustment dial. And an electronic clamping system is used to lock the tool carrier from movement while machining and unlock it to make these adjustments. Of course, this is a very simplified model of what occurs inside this tool to make these automatic adjustments possible, but the overall concept is the same. Now for the wireless communication capabilities of this tool. Just like wireless EWE boring tools that I talked about earlier, EWA automatic tools communicate over the same Bluetooth low energy protocols, which allow for the tool to communicate with smartphones and tablets. This gives the user the ability to send adjustment commands to the boring head wirelessly via their mobile device. These boring heads can also connect to Bluetooth-capable computers that communicate with the CNC machine controllers to open up the potential for a fully closed-loop automation process. The computer and CNC controller can share all these measurement data and command the head to make these adjustments all without an operator being present. And with newer CNC controllers, there is the possibility for the boring head to communicate directly with the machine, taking out the external computer and simplifying and automating the process even further. Here's a video on a fully automated machining integration with an external computer connected to a FANUC RoboDrill machining center. We first start with a machine touch probe measuring the current diameter of the existing bore, as you see here. Let's let that finish measuring. Notice the graphical UI at the bottom right. That would be what you would see on an external computer, or if a machine was able to have that displayed on screen. There you see the bore measurement, 72.990 millimeters. The target was 73 millimeters, so we're about 10 microns under size here. After this measurement, the computer receives this information, adjusts and verifies the EWAs set to this target diameter. Once verified, the machine will bore the hole with the EWA tool, as you see here. After this process, we go back to the touch probe so we can inspect this bore and get the actual measured diameter after this cut. So once we get the value here, we'll see how far off we are from the target nominal diameter. In this case, we are 3 microns under size. For this example, we're saying that this is a very ultra precise bore with a tolerance of plus minus 2 microns. So we are a little undersized under the tolerance band. This measurement is compared with the target diameter, as we figured out that it's 3 microns. So the computer sends an adjustment value of 3 microns to the EWA boring tool. That information is received and the boring tool does this automatic adjustment internally. For this example, the undersized cut of the bore was most likely due to cutting wear on the carbide insert. So for this, it's going to be compensating that. After this adjustment process is complete, the hole is remachined with the boring tool. And once that's finished, we'll do one more probing cycle in order to get the final dimension of this bore. So let's let that finish up and we'll see what the final bore measurement is. 73.001 or 1 micron over target diameter. So that falls perfectly within the tolerance band, and this is the end of the process. And there you have it, a fully automated closed loop fine boring cycle. No operator intervention was needed. So what are the benefits to all of this? The most obvious, of course, is the ability to have fully automated machining cycles. There are no more pauses needed in a machining cycle to conduct manual adjustments. And then unattended machining processes are now possible. This frees up the operator to work on other tasks like prepping new work pieces or operating other machines. It also reduces the chance of human error. An operator doesn't need to do these calculations anymore or make any manual adjustments that could lead to mistakes. It improves efficiency and reduces cycle times as well. The machine doesn't need to sit idle while it waits for an operator to come back and make the manual adjustments for the fine boring cycle. It can just do all of this automatically. Another key benefit, as seen from the video, is the ability to automatically compensate for cutting insert wear. The communication between the machine probe or bore gauge measurements and the boring head allow for automatic compensation to happen. The head can continue to adjust and reach this target machine diameter based upon the measurements from the touch probe, or it can generate an alarm message when the insert becomes too worn. And this can all be defined by the operator or G-code program. It's fully customizable here. This leads to reduced chances of undersized bores and especially scrap parts. Another benefit unique to some automatic boring tools that have large adjustment strokes like BIG KAISER's EWA tool is the capability to machine different size bores all with one tool. The AWA that you saw in the video has a wide adjustment stroke of greater than 3/4 of an inch in diameter or over 20 millimeters in diameter. This gives the ability to machine any hole size within that range and adjust for new sizes automatically. This removes the need for multiple tools set at different diameters. As long as the bore sizes fall in the cutting range of the EWA automatic tool, it should be able to machine all of them with just one tool assembly, which can reduce overall tooling costs, and it saves valuable space in the machine's tool chain for other machining operations and other tools. Well, this all sounds great. Where can I get one? Why aren't these already in the market? Well, BIG KAISER is in the development and testing phases for these EWA tools, like you see in this image here, and we're beginning beta testings at select facilities. We're hoping to have these tools available into the general market sometime in the coming years. But one of the biggest hurdles we've encountered that slows and holds back this cutting edge, pardon the pun, technology is machine communication. There is no universal standard for intra-machine communication, or device to machine, or more specifically, tool to machine. Inter-machine, or machine to machine communications and central monitoring methods do exist and are growing, but may not be fully adopted in every machine yet. These protocols like MT-Connect and OPC UA are great for machine monitoring and multi-machine analysis, but they were not originally designed for internal devices like machine tools to communicate with the machine control directly. This slows and complicates the integrations of these automatic boring tools with CNC machines, since integrations can only currently be done on an individual machine basis, with custom interfaces needing to be developed for every specific machine controller. It makes it really difficult to just have a universal integration method that could be essentially plug and play for a customer. If and when this intra-machine communication standard is developed and adopted, then the possibilities are wide open for automatic boring head integrations, or even other tool features like adaptive tooling that could monitor cutting conditions and even command the machine to adjust feeds and speeds to reach these optimal cutting conditions. But for now, tool manufacturers like BIG KAISER will continue to develop and push these exciting technologies out into the industry. Fine boring with automatically adjustable boring tools is in the not so distant future. So that concludes this presentation. Now let's go over any questions that you may have asked. So it doesn't look like we have any questions in here so far. But one of the topics that I could discuss about a little bit is why different machines don't have the same, or different machines aren't just immediately compatible with this automatic systems. Every machine builder currently has their own standard for intra-machine communications. Fanuc has Fanuc Focus, Heidenhain has a similar system, and all these other machine builders also have their own. And it's hard to just build one universal standard that'll work with everything. Another question that I get asked about is whether or not these tools can be, like I mentioned, be used for multiple different machining processes, different hole sizes and all that. It's kind of unique to our boring tools, which have such a large adjustment stroke, that you can do a bunch of different hole sizes as long as it falls in its range. Most automated systems usually can only compensate for insert wear and can only adjust out of maybe a thou or two. But our system, having the huge flexibility of it, almost 3/4 of an inch in diameter, gives it a lot more flexibility. And a customer can use this for all their machining needs. If you guys have any other questions in here, feel free, just send it in here. Another question that maybe I get asked about too is on the wireless technology for the EWE boring tools. Does an EWE boring tool always have to be connected to a smartphone or tablet in order to be used properly? No, of course not. The boring tool, the EWE boring tools act just like the old EWD, where you can actually just use it with that same display screen that's built into the head. But it adds the functionality of being able to connect with a smartphone or tablet or other device to be able to open up these other feature sets, like being able to see remotely the adjustment values, or sometimes more critically, sometimes reading the adjustment history, being able to see the last 100 measurements or 100 adjustments that you've made. Maybe you forgot what the last one was and you have to check on that. That's a perfect way to do it. Or like I mentioned before, shop managers being able to check on all of their boring tools, see what adjustments have been made by the operators. Maybe there was a time where they scrapped a part because the bore hole was too big, and then a shop manager can come in and see what adjustments were made on the head and maybe find out, oh, an adjustment was made that was way bigger than the tolerance was supposed to be. So all of this can be checked back because of the history recording of the head, something that you don't normally see on standard digital heads. And another question maybe about the analog heads would be something like, does that make analog heads completely obsolete or out of date? Not at all. Analog, the simplicity of it warrants it to be a more inexpensive option. But for most cases that you're not trying to hold tight tolerances, or maybe your operators are advanced enough or skilled enough to read those vernier markings, that's fine. But digital tools and in the near future automatic tools will help to make this process so much more efficient and time saving, which saves, of course, a lot of money. So with that, I don't see any questions in here. But of course, if you have other questions, then feel free to reach out to myself or Big Kaiser in general, and we'll be definitely happy to ask any of those or answer any of those. So I'll keep it open for a little bit to see if there's any other questions, and I'll try to come up with a question myself if I want to ask myself a question. Let's see. Oh, another question about automated process with the automatic boring heads. If you're using an external computer, does that mean that I need to have an operator at the computer to make sure that these things are running properly and make any adjustments there? No, of course not. The machine to computer integration, that was the customization section that I was talking about at the end, but that allows the machine to kind of control the computer, or vice versa, have the computer kind of control the machine's programming to allow it to switch back and forth and make all of these adjustments without any operator present. as long as the computer is running and connected to the machine, then everything can be done fully automated, which opens up the possibility for overnight machining or lights out machining or machining over the weekends where there's no operators present. That's all open now because automated fine boring is now a possibility. Before, of course, fine boring always had to have some operator there to make the adjustments manually. But if the head can do it itself, then you're fully automated in this case. Okay, I see, let's see a question in here. Give me 1 second. My window is cutting off the question, so I can't read it properly. All right, I have a question on here. Says, will EWA be able to be implemented on legacy equipment? So it all depends on how far legacy equipment can mean. A machine from the 1950s, probably not. But if the controller is network capable or has some sort of communication standard that the machine builder implemented and can work with external third-party devices like an external computer running a software application, then yeah, that's something that that is customized and can be built for it. You can have an old FANUC machine as long as it has FANUC focus libraries or APIs installed, then it will communicate directly with the computer and the application. So to answer that question, most likely yes, as long as it has network capabilities. Yeah, that was a great question. So if there are no other questions here, then we can conclude this. I want to thank you for attending this Tech Team webinar. Like I said before, feel free to contact us for any further information on topics discussed today or for anything else on BIG KAISER's product offerings. Thank you very much for attending and have a great rest of your day.